All right. Ugo plays hockey and is awarded 2 points per goal and 1 point per assist. Last season, she had 86 points. So this seems important information, right? It's telling us a little bit of information that we can be using in our expression, right? So I'm just gonna go ahead and highlight this. Total of 86 points, and she scored 17 fewer goals than assists. How many goals and assists did she earn? Well, if we look here, when we're talking about this total of 86 points, what do we really mean? All right, that was an ugly arrow. So, what do we really mean when we say that there's a total of 86 points? Well, these points are earned based off of the amount of goals and assists made. And you earn 2 points per goal while you earn 1 point per assist. So, these goals and assists make up your points. So, what we can say is 2G plus A, which equals 86. Now, the G and A are just variables that represent the amount of goals and assists, G for goal, and A for assist. And the reason why this is being multiplied by 2, as you can see with this coefficient, is because you get 2 points per goal. Every goal you have, you're gonna get 2 points. Not 1 point, but 2 points. So per is really like kind of like a mathematical code, you can think of it, for multiplication. Now that we have this expression, let's go ahead and just put it here. All right, just on this side, so I can do my work with it. All right, I believe that's important. All right, okay. So what we're gonna do is 2G plus A, which equals 86. Now, the issue with this problem is that we have two different variables here. If we have two different variables, we cannot simplify to a numerical value. We can only simplify to an expression, right? Like a mathematical expression. So what we need to do is we need to make sure that this equation only has either all G's or all A's. And the way we do that is with the next Q. I'm going to use blue for that. The next Q. And that is scored 17 fewer goals than assists. This is telling us direct relations between the goals and the assists. So we can model this relation in the form of a mathematical equation. So in this case, how I'm going to model it is through goals. So goals will equal, and then they're going to equal A minus 17. Now, what this means is that goals is, right? So I'm kind of translating it from mathematical expressions to English so it's more easier. So all I'm saying here is that goal, right? Goal is 17 fewer than assists. All right. Excuse my horrid handwriting, but um that's essentially all it's saying, right? Because with this minus 17, you're going to be taking out 17 assists, right? Which would mean that goal would be 17 less than assists. All right, cool. So now we have a modeled relationship between goals and assists, because goals is directly reliant on the amount of assists because of this information given in the word problem. So now what we can do is we can actually substitute this G with this relation, because A minus 17 is G and G is A minus 17, right? These two are equal, and that is confirmed with this equal sign. So let's go ahead and do that here. So we're going to say 2, and then we're going to put parentheses, and the reason why I'm putting parentheses is because we're treating this expression as one unit, right? We're treating it as one entity, right? Or one thing, whatever helps you understand it better. And then so we're going to add the A minus 17, and then we're going to add that with another A, which just comes from the previous expression, and then that's going to equal 86. Now we have some simplifying to do. First off, from the bat, I know that we're going to be using distributive property here. Why? Well, it follows the textbook form of distributive property. Excuse me. And that would be A, B plus C. You see, it's exactly like that. You have A here, you have A here, you have B here, and then you have C here. So what happens to this is it becomes A times B plus plus A times C. So if you wanted to write this in distributive property, because again, that simplifies the equation, makes it more easier to read and understand. Well, it's going to be 2a minus in our case. We use plus in the example, but in our case, the operation is a minus. So 2a minus, and then I'm going to put parentheses again, and this is just going to be 2 um time yeah, sorry, um 2 times 17. Yeah. Sorry, I was getting confused there. Yeah, 2 times 17 because this is A, this is our B, and this is our C. So then A times C and A times B, right? Okay, and then again, we're gonna have to add that A, and then that's gonna all equal to 86. So now what we're gonna do is we're gonna do 2A minus, and then we're gonna go ahead and multiply this, which gives us an output of 34, and then we're gonna add A to that, and that's going to equal 86. So now that we have simplified this part of the equation, right, using distributive property, let's go ahead and collect some like terms. And the like terms I see here is this 2a and this a. These two have the like term of the variable a. So we can just add these two together and get 3a minus 34, which equals 86. Okay, let me just make that a bit bigger. Okay, now as you can see, it's much more easier to use this equation because now it's been completely simplified. So what we're going to do now is we are going to isolate the variable, right? So once we isolate the variable, this is like grade 7 math, but once we isolate this variable, we'll get our numerical value. So what I'm going to do is I'm going to first remove this 34. And to remove it, all I need to do is do the opposite term, which is plus 34, which will cancel this out from here. But since this side and this side have to be balanced, if I do something on this end, like adding this 34, I have to do the same thing here. So then we're going to get a plus 34 on this side of the equation. So now what is left is 3a, which equals 86 plus 34. And what I'm going to do is I'm going to go ahead and simplify this by just adding them together. So if I add them together, I get 86 plus 34, which is 120, and then 120. And then what we want is we don't want 3 times a, we want just a singular a, right? We want the value of a itself. We don't want the value of a times 3 or 3 times a, which is what we have right now. So what I mean by this, just to be a little bit more clear, is that this expression tells us that 3 times a equals 120. But what we want to know is what 1 times a, or just a by itself, would equal. So to remove this pesky 3, all we need to do is just divide it by 3. But again, once we do something here, we got to do it here too. So then we divide 3 here, and then we can cancel this out because these two will cancel each other out, excuse me. And then we're left with a, which equals 120 divided by 3, and then a, which would become 40. Now a is the amount of assists. So if I go back up over here, I'm going to add my answers here. So I'll just call this section my answers, right? So within my answers, A equals 40, and therefore we have 40 assists. Okay? Now, um, to find out how many goals we have, we can use this relationship. Because remember, goals is reliant on the amount of assists, and we know the amount of assists. So it's just going to be goals, which equals 40 minus 17. And so then goals will equal 23. I'm just going to double check that. Yes, that is correct. And so then therefore, this symbol is just used for therefore in mathematics. And therefore, we have 23 goals. So in conclusion, this problem's answer for goals and assist is 23 goals and 40 assists. And if you double check your work, 23 plus 40 will give you 86, and 40 minus 17 will give you 23. And that's all thanks to the power of algebra and the expressions that are used within it.